Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, if you're new to the show, my name is Shawn Tierney from Insights in Automation. And this week on the show, I have another one of my interviews from Schneider Electric's Innovation Summit from late last year. This time, I'm interviewing Senior VP Hany Fouda. And we just have a great conversation about the future of automation and, where things are and where they're going. So I hope you guys enjoy this. But before we get to that, I got a couple of announcements. First, I want to thank Schneider Electric for sponsoring this episode so we could release it ad-free on all platforms. It wouldn't have been possible for me to go all the way out to the West Coast to film these interviews without that sponsorship. And so I appreciate them underwriting my costs so I could bring you this episode. Now, the second announcement is a PSA. Some of you may have noticed you haven't seen anything new from the Automation School this year on the YouTube channel. Well, the reason for that is the Automation School now has its own YouTube channel. So I split that off just like I split off the Automation Museum to its own YouTube channel. So it's youtube.com/@the Automation School. And I've already posted 3 or 4 updates up there. I got another one coming up this week. So just a PSA. If you want to know what's going on with the Automation School, we got some training coming up in April. I just sent out the dates to the wait list, and we got a lot of exciting things coming out on that side of the business. But for now, with those announcements done, let's go ahead and jump into this interview with Hany from Schneider Electric. Hany, thank you for agreeing to this interview. I just left one of your sessions, which was excellent, by the way. So I really appreciate you coming on the show. And I think you're the first high level
A senior vice president
senior
for
vice.
process automation. So, but I appreciate the opportunity, Sean. I mean, to talk to you and your audience as well. I'm sure they, hopefully it will add value to them and from our discussion. So,
Well, I definitely think it will. And just so the audience knows, I was a little nervous sitting down with a senior VP because usually we have engineers on product managers. But in his last session, which was phenomenal, he was just so personable, easy to get along with, just somebody you really want to just sit down and talk to. So thank you for coming on. I think we should start too by telling the audience what is your job? What
sure.
does that role entail?
Sure. So I'll give you a little bit background on myself, and then I'll focus on what I do day to day. I'm a telecom engineer. I was trained as a telecom and was drawn into the space of automation by accident. Right. I mean, the first project that I worked in was for Yoko, and I built up Yokogawa basically, which is more in the process, continuous process side. It was my first plant in an iron steel, and really my my job at that time as a young engineer was to service the control system that existed, that is running under the furnace, right? I mean, so normally you have the furnace pit, and then all the control and the I/O is running underneath the furnace pit in order to basically do the iron reduction and produce the steel. It was fascinating to me how the automation world, both discrete and continuous, actually combine a lot of what I learned in telecom, because you need to communicate, right? You need to share information across a large geographical area, which is the plant site, back to the operator who's sitting in a control room. So this is how it started. I worked for Yokogawa, I worked for General Electric and Schneider Electric now. Joined Schneider in 2010, and I, basically mainly in automation. Today, my day-to-day job is to decide on a number of things. One is the direction, the technology we are taking, where to put the money, right? Where to put the investment to develop, from an R&D perspective, technology. What is the value we're bringing to our owners, operators, basically the customers, both in continuous process, which is my area of focus, as well as in also in discrete automation, because some of the plants today are a combination of many things, right? Some of them have a cooking process, which we normally see in continuous process. They also have an element of hybrid process, especially around utilities, water, steam, and so on. And then also they could have a discrete process, which is basically part of the final production or final element, where you could have a little bit of robotics and so on. So my job on a day-to-day is to guide our team where to invest their time, their priorities in terms of developing the next generation or the R&D features that we need to drive and to serve our customers. I also another responsibility is to help serve our customers. So I always tell our team we need to stay relevant to our customers who are consuming this technology, because without them we will not be able to exist, right? I mean, if we end up having a development from a product perspective or solution perspective that nobody will buy, that's a failure, right? So I help navigate that risk in terms of differentiation in order to deliver a value to our customer. So at the end of the day, the end customer or the owner operator is the one who is signing the check to buy or deploy this technology. And I in the process, because nothing is perfect, support the customer in order to deploy it, get the maximum value out of it, and really see the return on investment as fast as we can. So that's my job on a daily basis.
That's amazing. And I think, we think about bakeries or baking, right? A lot of continuous process there, but also packaging. Once the product's baked, once the ovens, a lot of these ovens just run 24/7, but the products that come out of them have to be packaged. And that's usually the discrete part of the application where we have the individual, whether it's a loaf of bread or a donut or whatever you're
Right,
you're making, that has to be packaged. So those are some great examples of mixed
right.
applications. I appreciate that.
And it's funny. I mean, just talking about baking and packaging. Several weeks ago, I was visiting one of our very good customer in Sweden. I mean, they are a baking company. They ship their bread all across the Nordics, Scandinavia, basically. And what is critical for them is so they start at 6 p.m. in the evening, their shift, in order to get the bread by midnight out on the trucks to be in the store, ready and fresh for the population, for the customers, basically by 4 a.m. So this is the cycle of they cannot stop, right? I mean, you cannot come and say at 6 p.m. or as a control engineer, I'm going to upgrade this piece of software for you, right? Because that will present a risk in terms of production, right? I mean, you have a very tight production schedule, and they're not only doing bread, but they're doing pastry and so on and so forth. And all they have, their promise to their customer, their end user, is I deliver that to you fresh,
Yes.
right? So when you wake up at 6 a.m. in the morning, you go to the store, you pick up your bread, it's fresh. And this is how I see the role of control engineers, right? I mean, they make the promise, they deliver and act on the promise that their company or their organization relay to the customer, the consumer, or it could be business to business and so on. And I think it's a profession that people should be very proud of it, because without the control engineer, without having this flawless execution in terms of production, you may not get the bread. Or by the time it reach you, it would be not at the best form that it would be appealing and exciting. So this is just a quick example of as you said. I mean, how control engineers are helping.
Yeah, and I think, just thinking about it, a lot of people out there who are outside of this industry don't understand how much manufacturing is done local,
Yes.
right? And we know there's manufacturing done all around the world, and we need parts from all around the world. But a lot of people don't realize, like, your soft drinks,
Y-
your mattresses,
Yes.
as long as they're not like a blue foam or something, your
You cook.
anything that's
Yeah.
full of air,
Yes.
right, is not very efficient to ship, right?
Correct.
So in every major city that I've ever been to, there's been a bakery, a massive bakeries,
Correct.
massive breweries,
Correct.
massive soda pop plants, massive mattress factories, and all kinds of factories like that. Because I mean, even the cans they make for our soft drinks, it's not efficient to ship a pallet of those across state lines.
Correct.
And it gets kind of contentious when they run out of cans and one plant's not producing them and they're looking at the price of importing them. And that's why you'll see like customers who make that, they're all over the country
Right.
manufacturing those.
Not only that, Sean, but you also the evolution of our needs and as a consumer necessitate sometimes, for example, logistics centers. I mean, these are factories, right? If you take Amazon or Walmart, they have massive logistics centers closer to the population, right? In order to deliver the item that you order in 2 hours or next day shipment or whatever. And these logistics centers are fully automated or partially automated, depending on where they are in the spectrum. And this requires cobots, robots, some conveyors that is controlled definitely by programmable logic controllers. It requires security access so that people are in and safe, and so on and so forth. And all of this is part and parcel of control. I mean, control automation in general. So the other example that I always like to mention is recycling. Especially if you are in a state or a city that high on recycling, especially plastic recycling. Most of the plastic recycling is done in the urban area where the plastic is gathered, right? It's not shipped because it's very expensive to ship, obviously, to cross state line and also, across continents.
Yeah.
So recyclers are trying to recycle electronics and plastics closer where the raw material is gathered, right? And again, in order to recycle, you need control. There is no doubt about that. So there are many, many examples of, as you pointed out, how industries is local before being regional or on a continent scale. I mean, maybe automotive is across multiple countries because you move cars and you move components in the cars, but that's one piece of one space in the industry. There are many other spaces that are very close to the end customer.
And I really want to jump into what you were talking about at 12 o'clock session, your goal and that whole initiative with Schneider, not on the machine level, but on the automation level, the automation expert level, where we're talking about openness, right? And
Right.
I'd really like to get you to talk about that. I don't want to give away too much because I just sat through that session, but our audience didn't sit through that session. I think most of them didn't, anyways. So, can you talk about what your company's doing on that side of things
Sure.
with the openness initiative? Hey guys, just breaking in here for a couple quick announcements. First of all, I want to thank our sponsor this week. It is Schneider Electric, who made it possible for me to go out to their event and interview all these people. They really underwrote my expenses to do that, and I really appreciate that. So kudos to Schneider. If you see anybody from Schneider Electric, please thank them for sponsoring episodes of the Automation Podcast. I don't know how many we're up to now, 10, 12, 14, that they've sponsored over the years. So really appreciate that. And we got some really cool new stuff coming too from Schneider. That said, we have a second announcement, and that announcement is the Automation Podcast. Well, I'm trying to bring it to you every week. On the schedule coming up, I have a week where I have to spend it at a vendor site to train their people on PLCs. I got a week where I'm going to be giving talks to different organizations, and then I have a week of training here. So I'm going to try to continue to bring you an episode every week, but I can definitely see those weeks I'm out of town, it may not happen because there's nobody else to film and edit them except for me. So in any case, I just want to let you know, it's not because I don't care about you guys and don't want to bring you excellent episodes every week. I'm reaching out to vendors every day to try to get them to come on the show. And if you could reach out to them too, I'd really appreciate that. But, if I have an opportunity to train people for a week, I got to take it, right? And so, and of course, we want to fill up the training room here every month as well. And, when you get an opportunity to fly somewhere and speak in front of a group, you want to take that as well. So in any case, I know you guys would understand, but just wanted to prep you. I don't have any firm dates yet, but I'll keep you posted as we release more episodes of the show. And so with those announcements out of the way, let's go ahead and jump back into this week's episode.
Sure. So Schneider Electric took about a number of years ago to drive the industry and certainly ourselves and our solution towards open software-defined automation, and this across all verticals in the industrial automation space. So continuous process, where obviously, as I said, I mean, continuous process is all about cooking something, right? I mean, it's more or less, if you have, a refinery or petrochemical and so on, it's about extracting something from something else, right? As a feedstock, either from oil, gas, and so on. And it requires definitely a lot of steam, a lot of energy, in order to break down, the molecules in the certainly the feedstock, and build something out, to create plastics and so on. So that's a continuous process space. And then you have the utility, water, wastewater, which normally also can be attached to some of these plants in order to to supply water, obviously, because you consume a lot of water, as well as treat the wastewater, the outcome. And then you have certainly the discrete side, where we're talking about logistic centers and, as we said, recycling and so on. So all across these three pillars, we're driving open software defined in order to help our customers navigate and improve their responsiveness to the market needs. One story, for example, one aspect, uh, automotive, right? If you think about building a car, you have a production line. Obviously, we perfected that since Ford started the industrial revolution around automotive, and how to build a car together. The same concept have been with us for many, many years. Now, automotive companies and suppliers, in the auto industry, they want to have the same production line shifting between ICE, an internal combustion engine, hybrid, and full EV in a matter of weeks, not in a matter of months, right? Depending on the demand. If the demand is coming back to internal combustion engine, then we the production line becomes an internal combustion engine production line, the same production line. Or it shifts to hybrid, the same production line is fitted very quickly and adjusted very quickly to build hybrid cars, and so on. So this agility in the production does require more open, more less verticalized systems, which really give you the power to shift from one control strategy to another control strategy very, very easily. Right, and this is what we are, driving with open software defined automation. So, in a nutshell, open software defined automation is basically the hardware independency between the software layer and the hardware below. So you're not locked in with a single vendor for the hardware. You actually you invest your control IP in the software, but the hardware can be interchangeable depending on the speed of the evolution of technology. It's the same as your laptop. I mean, if you buy a laptop today, you expect that this laptop will last you for 3 years before the computing power and the software evolution or the new software features coming up and require you to upgrade your laptop, right? We don't do that in industrial automation. We stick with our hardware for as long as we can, maybe 5-10 years, and this is started to change, where you every time you get a computing power, you can actually freely upgrade your hardware from one vendor or another, but the software layer, which is your equivalent to the Microsoft Office, is still the same, right? So you can move, as you do as a consumer, from one laptop or one pad to another, depending on your needs, depending on your computing power, how much memory you need, how much graphics or video you want to store, and so on and so forth. So this is the same concept is in open software defined. It gives you hardware, reduce the hardware dependency or hardware interdependency, remove that, give you the ability to upgrade when needed in order to be more agile, give you distributed application, so that you can distribute your application in a much better way to rejig your production line as needed. It gives you much more application centricity, so that you can actually repeatedly deploy the application as needed, depending on how you want to scale your operation. And it's digitally native. So the digital connectivity is built in, so that when you move to an AI application that require a lot of data in order to run, certainly to consume in the model and give you decision support, the data is there.
Yeah, it's really, I mean, just my opinion, it's really a next generation conceptually looking at what automation needs to become from a like next generation standpoint. And I know I was blown away. We had Louis Aron on, I think 4 years ago, and he kind of went through, he was talking about universal automation. And I know a lot of things have probably changed since then,
Right.
but it was so interesting. And I appreciate you going through that and explaining that from kind of like the everyman, or I should say every engineer's perspective
Right.
to kind of spell that out. And I got to find somebody, I'll have to talk to you after the show to see if we can find somebody technical to come on and really get into the bits and bytes because, some engineers just like the bits and bytes.
Absolutely, and they're rightly so. I mean, because they, they need to buy into it, right? And we at Schneider, we love to talk to people in order to tell them how this concept can help them to do their job better. It's not this, there is a misconception that our control engineers will not be needed in the age of AI, and that's it's absolutely not true, right? I mean, there always going to be a human intelligence
Yeah.
combined with AI, with artificial intelligence, and that's very critical for people to understand. We just need to up our game, right? Because the AI will help us actually to see the anomalies much faster. The 0.0001% of productivity that we can extract from the line, or the improvement that we can do, or energy, less energy consumption, because
Yeah. That,
when you multiply that by yeah, basically 12-hour shift or 24-hour shift across the year, if you can extract this 0.0001 saving, it really adds up over a number of years.
oh, absolutely.
AI will help us do this anomaly, or and help us get the prediction. But the human intelligence is where the decision will be, and this is what I would appreciate our control engineer to drive their ideas and thinking towards that themselves, into the direction of how can I leverage all the information that's coming to me through AI, or through my control system that is more software defined, to really make a better decision around my production, or my facility, or my operation.
Yeah, and I think what Schneider's doing in this area is amazing. I talked to Mahua earlier, and we're going to have her on the show to talk about the assistant AI. And I know I'm getting the hook from the staff here. So in any case, the crew's been so good to us. But Hany, I want to thank you for coming on the show and really appreciate your time. And by the way, you are the first senior VP we've ever had on the show. Thank you
Would it
very
be
much.
the last, for sure, Sean? Thank you very much. Appreciate your time. It was fun.
Well, I hope you enjoyed this week's episode. And I want to thank Haney for coming on the show and having that conversation with us about the future of automation. It's so interesting to see how they're driving the future of their products based on, that reasoning. And I thought it was really cool and super interesting. I hope you guys did too. I also want to thank this week's sponsor, Schneider Electric, for, underwriting our costs so we could release it on all platforms ad free. Really appreciate that. And I want to thank you, our audience, for tuning back in this week. Again, if you guys want me to have somebody on the show, just reach out to them, or reach out to me, or send me their name, or send them my name, because we want to cover the cost, the vendors, and the topics you want to hear about. So with that said, I want to wish you all good health and happiness. And until next time, my friends, peace.